A new study claims to have discovered a solution to the mystery of dark matter, but it is based on the discovery of a particle that leads to the discovery of another dimension. Scientists believe the particle could serve as a portal to the fifth dimension. So what exactly is the particle in question, and how was it discovered? Is it true that we've entered the fifth dimension? We'll find out in this video. The sci-fi hypothesis was published in a new study in the European Physical Journal C. It implies that the particle can explain dark matter, which has never been directly observed, but it is thought to account for the vast majority of the mass in the universe. Particles, according to the researchers, can travel throughout the universe, including into the fifth dimension. Our understanding of the physical universe is based on the concept of dark matter, which accounts for the vast majority of matter in the universe. Because many features would dissolve or fall apart without the X-factor of dark matter is a kind of pinch hitter that helps scientists explain how gravity works. Even so, dark matter does not disrupt the particles we see and feel, implying that it must have additional properties. For years, scientists have questioned the known 4 dimensions of our universe. There are 3 in space and 1 in time. The extensive research, according to the source, has resulted in 5D equations that express the implications an extra dimension would have on the universe and reality itself. The scientists created a new scalar associated with the fermion while studying 5D equations in relation to fermion particle masses, which they claim is analogous to the Higgs field and Higgs boson particle. We discovered that the new scalar field had interesting, non-trivial behavior along the extra dimension. The scientists told the sources, if this heavy particle exists, it must connect the constituents of visible matter that we know and have studied in depth with the constituents of dark matter, assuming that dark matter is made up of fundamental fermions that live in the extra dimension. The author's right. The simple part is to speculate to the particle. Now it is up to the scientists to go out and find it. To put it in context, despite being proposed in 1964, the Higgs boson was not discovered until 2012. The Large Hadron Collider, the world's largest and most powerful particle accelerator, discovered the Higgs boson. However, it would be too small and ineffective to detect this new particle, which is too heavy for current colliders. Despite this, the researchers are confident that the particle can be detected indirectly. This new particle could play an important role in the cosmological history of the universe, and it may produce gravitational waves that can be searched for with future gravitational wave detectors, the researchers said. The Large Hadron Collider began smashing subatomic particles together in 2010, sparking fears that scientists had unintentionally brought about the end of the world. Some feared that the experiments these scientists were conducting with the LHC would result in the creation of a small black hole, sucking in everything around it and eventually engulfing the entire world. These critics were clearly wrong. We're still here in 2022, and while it can sometimes feel like we're in hell, we're still a pre-apocalyptic society for the time being. In fact, the LHC ran successfully at the European Council for Nuclear Research headquarters for several years before being shut down for updates in 2018. The particle accelerator facilitated some of the world's largest international science collaborations at the time, leading to the discovery of an elementary particle known as the Higgs boson. Doomsday fears are resurfacing, however, as the Large Hadron Collider enters a new phase of experiments, resulting in collisions with unprecedented energy levels. People are concerned about more than just black holes this time. Consider hellgates, demonic portals, and multiverse portals. This is what we can expect from the start of the experiments today, if the conspiracy theories are correct. Everything you need to know about the theories and what's going on 175 meters beneath the France-Switzerland border can be found right here. The LHC is the world's largest particle collider, housed in a 17-mile circumference tunnel buried up to 175 meters deep near Geneva by CERN between 1998 and 2008. What exactly does it accomplish? It propels high-energy particle beams to near-light-speed collisions at 4 points. The goal is to answer some of physics' most fundamental questions, ranging from subatomic particle relationships to theories of space and time, as well as Einstein's theory of relativity. Attempts to sue CERN for endangering public safety have been made in the past, implying an underlying fear about the side effects of using the unprecedented technology. The two main concerns about using the Large Hadron Collider are black holes and the eerie-sounding strange matter. The first is self-evident, One of the LHC's goals is to simulate microscopic black holes containing information about the Big Bang. Hearing this sounds like a bad idea to someone with little to no technical knowledge. The second concern is that the high-energy LHC experiments will produce stranglets, a hypothetical material made of strange matter that will infect the rest of the Earth's material. That's a lot of quotation marks for a reason. Strange matter is currently purely hypothetical and has yet to be observed in outer space, where high-energy rays bounce around all over the place. The LHC reopened earlier this year after 3 years of upgrades and maintenance. Beams have apparently been circulating in the accelerator since April and are now stable enough to resume testing at higher energy levels than ever before, with a nearly 4-year runtime. As a result, social media is flooded with panic. This hysteria comes in a variety of flavors in 2022, in keeping with the internet's spiritual awakening in recent years, which has seen conspiracy theorists shift away from the big pharma and secret military operations and towards Satanism, witchcraft, and the return of Atlantis. One Twitter user writes, "On July 5th, CERN will open a multi-dimensional portal that will use dark matter. Everything is in working order." Another user concurs that CERN is on track to open a space-time portal, adding, "They began getting it ready when the planets aligned on June 24th. To be sure, some scientists are looking into the possibility of a multiverse in relation to the Higgs boson, a theory that will most likely evolve as more data is gathered in the coming years. Basically, if something truly disastrous was going to occur, it would have occurred by now. If there's one thing that I've learned from popular science fiction, it's that if a research lab claims that they're not opening portals to parallel universes, my instinct tells me that they're most likely opening portals to other dimensions, so it's easy to see why people are skeptical. The study, according to the researchers, is not about creating portals to other dimensions. Instead, they entailed looking for new ways that matter we know and understand, which constitutes our universe, might interact with dark matter, which constitutes the majority of our universe and is unknown to us. It also explains why particle physicists use the figurative term portal. Following the publication of her research, people began drawing parallels to the Netflix show Stranger Things, a show about kids discovering a shady government agency opening portals to other dimensions full of monsters, aired in the 1980s. Despite the fact that the show demonstrated that entering parallel universes is a bad idea, people continued to request volunteers to explore the new strange worlds they imagined would be discovered. So what is the Oak Ridge National Laboratory up to? They're basically looking into the possibility of a neutron passing through a wall. They used a magnet to pull the neutron through a tube with a blocked end. The neutron is expected to come to a halt at the wall. They believe it must have discovered a way to portal through the wall if it gets through. What are your thoughts on this? The neutron did not, as previously thought, phase portal of teleport through the wall. They found no evidence of parallel universes or new neutron-dark matter interactions. However, all hope is not lost. Researchers speculated that neutrons could be converting to dark matter in ways that the experiment isn't sensitive to. The team plans to conduct more sensitive searches in the future in a high-flux isotope reactor, which, we are confident, will not open a portal to hell.
Former U.S. security contractor Edward Snowden was granted Russian citizenship after leaking highly sensitive information from the country's National Security Agency in 2013. In this video, we'll take a look at the most recent terrifying leaked file, which has shocked the entire world. The 39-year-old whistleblower shared classified information about top-secret NSA programs, including the PRISM surveillance program, with The Guardian and The Washington Post, which both published their first exposes in early June 2013, while he was still an agency employee and subcontractor. Snowden's leak of thousands of documents sparked lengthy and heated debates about the balance of national security and individual privacy, earning him both praise and treason charges. The first leak, based on top-secret information stolen from the National Security Agency by then 29-year-old Edward Snowden, was published in June 2013 by The Guardian. Snowden was working for Booz Allen Hamilton as an intelligence contractor in Hawaii at the time. That would almost certainly not be the final leak. Journalists have released approximately 7,000 top-secret documents entrusted to them by Snowden in the years since, which some claim is less than 1% of the overall database. Snowden was born on June 21, 1983, in the U.S. state of North Carolina. He dropped out of high school and attended a community college on an irregular basis between 1999 and 2005. Snowden enlisted in the Army Reserve in 2004 as a Special Forces candidate, but was discharged the following year. In 2005, he worked as a security guard at the Center for Advanced Study of Language, a University of Maryland research facility affiliated with the National Security Agency. He was hired by the CIA in 2006 after demonstrating his computer skills without a formal education. Snowden left the CIA in 2009 to work as a private contractor for Dell and Booz Allen Hamilton at the NSA. He began gathering information about various NSA activities, including the classified surveillance program. After obtaining medical leave, he traveled to Hong Kong in 2013, just before his leak became public. The scandal broke in early June 2013 when The Guardian newspaper reported that the U.S. National Security Agency was collecting tens of millions of Americans' phone records. The secret court order directing Verizon to hand over all of its telephone data to the NSA on an ongoing daily basis was published by the paper. Following that report, revelations in The Washington Post and The Guardian revealed that the NSA tapped directly into the servers of 9 internet companies, including Facebook, Google, Microsoft, and Yahoo, to track online communication as part of a surveillance program known as PRISM. GCHQ, Britain's electronic eavesdropping agency, was also accused of using PRISM to gather information on online companies. Shortly after, The Guardian revealed that the leaks about US and UK surveillance programs were the work of ex-CIA systems analyst Edward Snowden. In the United States, he has been charged with theft of government property, unauthorized disclosure of national defense information, and willful disclosure of classified communications intelligence. On 21 June, The Guardian reported that the UK spy agency was tapping global communications fiber optic cables and sharing massive amounts of data with the NSA, its US counterpart. The newspaper revealed that it had obtained documents from Edward Snowden revealing that the GCHQ operation, codenamed Tempora, had been in operation for 18 months. According to the report, GCHQ had a larger data collection than the US, tapping into 200 fiber optic cables to monitor up to 600 million communications every day. The data from internet and phone use was allegedly kept for up to 30 days before being sifted and analyzed. Although GCHQ did not violate the law, The Guardian speculated that the existing legislation was being applied very broadly to allow such a large volume of data to be collected. On October 24, the Italian weekly Il Espresso reported on GCHQ and NSA eavesdropping on Italian phone calls and internet traffic. Edward Snowden was cited as the source of the revelations. 3 undersea cables with terminals in Italy are said to have been targeted. Enrico Letta, Italy's prime minister, called the allegations inconceivable and unacceptable and said he wanted to know the truth. After fleeing to Hong Kong, Edward Snowden told the South China Morning Post that the NSA was responsible for over 61,000 hacking operations around the world, including many in Hong Kong and mainland China. In Hong Kong, he said targets included the Chinese university, government officials, and businesses. We hacked network backbones, which are basically huge internet routers that give us access to the communications of hundreds of thousands of computers without having to hack each and every one, Mr. Snowden was quoted as saying. According to Germany's Der Spiegel magazine, claims surfaced on June 29 that the NSA had also spied on European Union offices in the US and Europe. I am deeply shocked, says Martin Schulz, because I believe the United States should treat the European Union as a partner, not an adversary. According to the magazine, leaked NSA documents show that the US spied on EU internal computer networks in Washington and at the EU's UN office in New York. Edward Snowden, according to the paper, showed it the top secret files. One document dated September 2010 explicitly named the EU representation at the UN as a location target. Der Spiegel wrote, according to the documents, the NSA also conducted an electronic eavesdropping operation in a building in Brussels that housed the EU Council of Ministers and the European Council. It is unclear what information US spies may have obtained, but observers say details of European positions on trade and military matters could be useful to those involved in US-EU negotiations. After German media reported that the NSA had eavesdropped on Chancellor Angela Merkel's mobile phone, the German government summoned the US ambassador on October 24 an unusual step. The allegations dominated a European Union summit, with Merkel demanded a full explanation and warned that trust between allies could be jeopardized. She spoke with U.S. President Barack Obama on the phone about the situation. He'd assured her that her calls were not being monitored at the time and would not be in the future. However, the White House did not deny previously bugging her phone. Past secret police surveillance, whether Nazi or communist, has made Germans extremely sensitive to privacy issues. Merkel grew up in the former East Germany, where the Stasi spied on millions of citizens. Meanwhile, France's President François Hollande expressed concern about reports that the US had monitored millions of French phone calls. According to The Guardian, the NSA monitored the phones of 35 world leaders after being given their phone numbers by another US government official. The report was once again obtained from Edward Snowden. According to a secret file obtained by The Guardian, 38 embassies and missions have been targets of U.S. spying operations. The paper reported on July 1 that countries targeted included France, Italy, and Greece, as well as America's non-European allies such as Japan, South Korea, and India. The EU embassies and missions in New York and Washington were said to be under surveillance as well. The file allegedly detailed an extraordinary range of message interception methods, such as bugs, specialized antennae, and wiretaps. The codenames of alleged operations against the French and Greek UN missions, as well as the Italian embassy in Washington, were also mentioned in the Guardian report. Activities to protect national security, according to U.S. Secretary of State John Kerry, are not unusual in international relations. The revelations in Brazil's O Globo newspaper on 10 July that the NSA ran a continent-wide surveillance program outraged U.S. allies in Latin America. The paper cited leaked documents indicating that the NSA ran the operation from a base in Brasilia until at least 2002, seizing web traffic and phone call details from across the region. U.S. agents allegedly collaborated with Brazilian telecommunications companies to spy on oil and energy companies, foreign visitors to Brazil, and major players in Mexico's drug wars. Mexico, Brazil, Colombia, and Chile all demanded answers from the U.S., but the revelations about Latin America kept coming, and in September, more specific claims emerged that the presidents of Mexico and Brazil's emails and phone calls had been intercepted. In addition, the U.S. had been spying on Petrobras, Brazil's state-owned oil company. In the most high-profile diplomatic move since the scandal broke, Brazilian President Dilma Rousseff canceled a state visit to the United States. According to documents obtained by the Washington Post in mid-August, the NSA violates U.S. privacy laws hundreds of times each year. The papers revealed that U.S. citizens were inadvertently spied on for reasons such as typos and system errors. In one case in 2008, a large number of calls were intercepted after a computer program error entered 202, the telephone area code for Washington, D.C., into a data query instead of 20, the country code for Egypt.
Scientists discovered 2-billion-year-old nuclear reactor that changes everything. Before we move on with the video and unravel some mind-blowing facts, take a moment to subscribe to the channel and ring the bell icon. Nuclear energy is the energy produced from nuclear reactions such as decaying, fission, and fusion. The world is trying its best in order to make a dramatic shift towards nuclear energy, because the production of nuclear energy is clean and poses no threats to our climate or contributes to climatic issues like many major energy generation sources do. Nuclear energy, as mentioned earlier, comes from nuclear reactions which produce energy and fuel for these reactions. Radioisotopes are simply said radioactive isotopes. In today's world, all of the nuclear energy comes from fission reactions. That is, the splitting of radioisotopes like uranium or plutonium into more stable and smaller atoms. This splitting of radioisotopes produces energy which we then use. The best thing about nuclear fusion reactions is that they can be long-lasting chain reactions, which makes them perfect to be used as fuel for space exploration missions through radioisotopic energy sources. Radioisotopes can be used in several other aspects such as criminal identification, protection of crops, medical, and much more. On top of that, a significant portion of the world's electricity comes from nuclear energy because the heat released by nuclear reactions is used to heat water to produce steam, which then turns the turbines to generate electricity. Nuclear energy has many uses and advantages, and at the same time, it has little to no carbon emissions, which makes it an incredibly environmentally friendly source of energy. Nuclear power plants are nothing easy to build, taking into account the complexity of the processes involved. However, once set up, a nuclear power plant produces a lot of energy. Nuclear fission and fusion reactions are the energy-generating reactions that are initiated within nuclear reactors, where they are controlled because let me just warn you that these are chain reactions which, if not properly controlled, can gradually release dangerously high amounts of energy, which can result in nuclear explosions. Hence, careful monitoring and management are vital at nuclear plants. If we trace down the evolution of nuclear reactors, we discover that the first nuclear reactor was built in 1942 by Enrico Fermi, and since then, over 400 more have been built and more are under construction. However, a recent investigation has concluded that the first ever nuclear reactor dates back to 2 billion years ago. That's flabbergasting because the question that arises here is that there was no human science 2 billion years ago. So how come did such a reactor exist back then? This video will answer this question. In the early 1950s, scientists suspected that naturally occurring nuclear reactors might have graced the planet. And sooner, a report by scientists suggested that conditions needed for nuclear fission to start naturally, which were 16 years later proven correct. Further investigations and experiments uncovered the fact that 17 naturally occurring nuclear reactors operated in an area today called Gabon in Western Africa. These reactors, although didn't produce huge amounts of energy, they kept running for hundreds of thousands of years naturally. This entire mystery started concerning scientists when they extracted uranium ore from the Oklo mine in Gabon and ran some tests, and to their surprise, got some shocking results. Naturally, uranium ore consists of isotopes of uranium in which uranium-238 is the most abundant, while uranium-234 is the rarest. What matters the most to the scientists is uranium-235, because it is used as fuel in nuclear reactions. Naturally, a uranium ore contains 0.72% uranium-235. However, when tests were conducted, scientists discovered that their samples contained 0.717% of uranium-235, which does sound like a minor difference, but to the scientists, it was a question of where. Where did the remaining uranium go? It meant that nearly 200 kilograms of uranium had been lost. But how? This further raised the speculation of something extremely unique to have occurred, and later scientists concluded that the 0.003% of uranium-235 had basically undergone nuclear fission to split into smaller atoms. But then, scientists were greeted with the question of how. How did fission occur without a nuclear reactor? Which suggested that a naturally occurring nuclear reactor existed roughly 2 billion years ago, and was responsible for the depletion of uranium-235. This was hard to believe considering that for nuclear fission to occur, certain conditions are needed. Scientists were further blown away by the fact that there were 16 other naturally occurring nuclear reactors that had existed. Different scientists explain this happening in different ways because for nuclear fission to occur, Gabon's climate and terrain seem suitable, but an explanation for the plentiful supply of uranium-235 needed to initiate fission, adequate amounts of neutrons, and the presence of a regulating substance like water remained a mind-boggling question. The most logical and valid explanations describing this phenomenon suggested that 0.720% of uranium-235 was adequate enough to initiate a fission reaction, and that the initiating neutron came from the natural decay of uranium-235, which produces thorium and neutrons. They then explained that there was a natural flow of water that served the purpose of a regulating substance, and that the energy released by the reaction heated up the water to a point that all of it eventually boiled, leaving no regulating substance to control the neutrons, which brought the entire natural system to a halt. They further suggested that this process kept repeating as the water then eventually condensed to act as the regulator and the reaction started again. However, eventually the uranium-235 was used up, and the remaining wasn't enough to start the fission reaction again. These natural nuclear reactors on average produced a power of 100 kilowatts, which is equivalent to powering 1,000 light bulbs, compared to current nuclear power outputs of 1,000 megawatts, which is equivalent to powering 10 million light bulbs. Additionally, long-term geologic storage of nuclear waste is possible because Gabon's reactors have proven to store various radioactive byproducts for up to 2 billion years. Scientists have unraveled the mystery of Gabon's naturally occurring nuclear reactor. They remained stunned and are curious to know why didn't such a nuclear reactor occur naturally anywhere else on Earth. All these 17 natural reactors were unique, and although most of them have been mined out of it, was suggested later on that at least one should be kept preserved and must not be mined out for present and future research. as this was not something common or something that might happen again. These natural nuclear reactors have answered plenty of questions for scientists, which may enable them to further enhance the development of existing commercial nuclear reactors and their handling. Because Gabon's reactor also helped scientists to investigate the method of geologically storing nuclear waste in the long term. Scientists also wondered as to why didn't these reactors spread across the terrain to gain abundance. However, all that counts on the research of these reactors, and that would be possible upon having a nuclear reactor naturally preserved, because there may be many valuable ideas and methods that these reactors may teach us. You might also question, why did these nuclear reactors emerge only 2 billion years ago and not earlier or after, right? After all, it is puzzling to think why don't new natural reactors emerge and why these natural reactors trace back to more than 2 billion years ago. Well, the answer to that question is quite satisfying, because you should know that for nuclear fission to initiate, a certain amount of uranium-235 is needed, otherwise initiation of the fission reaction is not readily possible. Additionally, investigations and tests tell us that the amount of uranium today has depleted, and it doesn't satisfy the requirement to begin fission naturally. Therefore, in today's world, none of such phenomena have been discovered. And as far as the early days are concerned, uranium-235's proportion in the Earth's crust was never as high as 2 billion years ago. If we go back in time more than 2 billion years ago, there was very little uranium-235 concentration, which didn't help in starting nuclear reactors naturally. However, when oxygen's proportion increased, the uranium-235 oxidized and its amount increased, which enabled the uranium-235 to undergo fission naturally. And that's just how 2 billion years back in time was the perfect time to start the nuclear reactors naturally. Conditions perfectly aligned with what was needed, and this mysterious process began happening. The discovery of uranium-235's ability to undergo fission naturally has already opened a lot of doors for further development in the science of nuclear reactors. This mysterious discovery has told us one thing for certain, and that is, long-term geologic storage of nuclear waste is possible without any harm, and it's only a matter of time before research is conducted and more stuff is discovered. Do share your thoughts in the comment section below as to whether or not did you find this video to be an interesting one. And if we missed something important, suggest that in the comments too. James Webb Telescope refute the Big Bang Theory. The James Webb Space Telescope was eagerly anticipated before its launch last year. However, now that the world's most potent and costly telescope is operating, the JWST has the potential to flip astronomy on its head with a single discovery. The newest JWST photos indicated that the Big Bang hypothesis did not occur, infuriating the scientific community. Welcome back to our channel. In today's video, we will be talking all about how James Webb Space Telescope proved the Big Bang hypothesis false. Don't forget to subscribe to our channel. The James Webb Space Telescope achieved a new record in terms of labor hours. During decades of development, the telescope consumed millions of hours. With a cost of $10 billion, no other telescope compares. Because it had to fit with the launch rocket, the James Webb Space Telescope was also an engineering challenge. Engineers had to design it to fold in many places since no rocket could hold it. The giant heat shield had to be unfolded as it went to its permanent home, and it wasn't even the most dangerous aspect of the telescope. The reflecting mirror, the focal point, had to be dismantled and folded into 18 parts. It was suspectable due to the plethora of possible difficulties, and the engineers and scientists who worked on it held their breath during the launch. Their fears were exacerbated by the fact that the JWST is virtually beyond repair or upkeep. The telescope is 1 million miles from Earth, making it difficult to dispatch a repair crew if anything goes wrong. Because there is no prospect of recharging, the mission ends when the fuel runs out. However, the risks connected with the JWST are significantly surpassed by the advantages. It promises to expand our knowledge of the cosmos in ways no scientific instrument has. Consequently, scientists from across the globe have been lining up to use the massive telescope to probe SEIS since it was declared operational. However, none of them were prepared for one of the worst revelations the telescope had in store for them immediately. After just a few weeks of operation, the James Webb Space Telescope has already generated photos that disprove the Big Bang hypothesis. Because of the popularity on the blockbuster TV program The Big Bang Theory, the Big Bang has become the gospel of astronomy, and many people use it to explain the universe's beginnings. The Big Bang idea is based on the work of a priest-turned-astronomer George Lemaitre, who proposed in 1927 that the universe initially originated as a single point. He argued that the cosmos has grown and extended to its present extent and could do so indefinitely. A few years later, Famed astronomer Edwin Hubble, for whom the Hubble Space Telescope was named, expanded on Lemaitre's proposal. Hubble discovered that other galaxies were moving away from us and that distant galaxies were moving faster than close ones. The astronomer deduced that the cosmos was still expanding, just as Lemaitre had predicted. If objects were going away, they had previously been closer together. According to the Big Bang hypothesis, when the universe started, it was nothing more than hot, tiny particles mixed with light and energy. The temperature lowered as everything grew and took up more space. The tiny particles then clumped together to create atoms, which eventually clumped together to form the stars and galaxies we see today. These early stars created bigger atoms and atomic groups, resulting in the development of new leads. Galaxies crashed and fused into a chaotic cosmic show at the exact moment. As new stars created and died, other objects like asteroids, comets, planets, and black holes formed. All of this occurred over 14 billion years ago. But what if the Big Bang didn't happen? While many scientists may be hesitant to consider this notion since it has been a cornerstone of contemporary astronomy, the JWST is unapologetic with its most recent batch of photographs. While the public is charmed by the JWST's breathtaking photos, scientists struggle to explain their discrepancy with the Big Bang hypothesis. The photos have the disadvantage of depicting several galaxies that are strikingly smooth, tiny, and ancient. But why do smooth, tiny, and ancient galaxies defy the Big Bang theory? Begin with the overly slight angle. Assuming the universe is expanding, an unusual optical illusion must occur. The fact is that galaxies and other naturally occurring objects in space do not become smaller as they go further away. They should become more prominent and more significant after a specific time. Consider this, if you're wondering why. It's because their radiance is meant to have faded. They moved in closer, the opposite of what we experience in non-expanding space when things look smaller in proportion to their distance. The presence of smaller galaxies in JWST photos cannot be disguised by scientists who have examined them. These photos depict galaxies 2 to 3 times smaller than those seen in Hubble Space Telescope photographs of galaxies with brightness and mass more excellent than the Milky Way. The redshifts of the new galaxies are also 2 to 3 times greater. It is not predicted that an expanding universe will behave this way if the universe is not expanding and redshift is proportional to distance. The JWST discovers galaxies that are precisely the same size as the closest galaxy to us. To compensate for the positive optical illusion caused by the Big Bang, these distant galaxies must be inherently tiny. The GHz 2 has a far greater illuminance than the Milky Way. However, calculations show that its estimated radius is merely 300 light-years or 150 times that of the Milky Way. Its surface brightness or brightness in terms of area would be 600 times that of the closest galaxy. Its density would be millions of times larger than the density of the galaxies we can see now. Mighty Mouse galaxies, which are small, highly dense galaxies, are required for the Big Bang hypothesis to be correct. James Webb Space Telescope has exacerbated the situation significantly. According to the hypothesis, tiny galaxies evolve into modern galaxies by colliding with one another, causing them to combine as they spread out. To demonstrate this form of fusion, imagine an excellent small automobile that is a centimeter long yet weighs as much as an SUV. Consider it was colliding with a slew of other magical vehicles as it evolved into a genuine SUV. This is when the JWST photos begin to undercut the Big Bang idea. Even though the representation seems impossible initially, you can expect to observe some wonders in the collision autos. Therefore, proponents of the Big Bang theory anticipated finding galaxies with significant scars or rough edges from the impact they experienced or survived. However, the JWST's revelation of extraordinarily smooth disks and perfect spiral patterns caused them off guard. Their appearance is identical to that of current galaxies. Data revealed that the images had almost 10 times as many smooth spiral galaxies as the theory expected. This casts doubt on the notion that galaxy mergers occur frequently. In other words, this information refutes the merger theory. Now, what happens when galaxy mergers are few? The thing is that galaxies cannot become so massive without merging. This implies that more giant galaxies have always been enormous and have never been small. It also implies that the optical illusion that expanding universe theory predicted does not exist. Since the absence of illusion indicates the lack of expansion, the illusion is unavoidable increased prediction. Next, let's examine the two historical aspects. This is similar or same as too many. The JWST uses a variety of filters to capture images in the infrared region of the spectrum. Astronomers can see the colors of far-off galaxies thanks to this. Astronomers use it to determine how old the stars are in these galaxies. Older, more excellent stars are yellow or red, whereas scorching young stars are blue. According to the Big Bang Theory, the most distant galaxies in the JWST images are currently visible as they were 400 to 500 million years after the universe's creation. But some of these galaxies have star populations that are more than 1 billion years old. These galaxies prove that there was no Big Bang since nothing could have existed before. Since there can be a galaxy older than the Big Bang, the more backward the JWST scans, the fewer galaxies it should observe. If the Big Bang Theory is correct, it would eventually stop observing galaxies or descend into the dark ages of the cosmos. However, scientists are showing that even 100 million years after the alleged Big Bang, galaxies as massive as the Milky Way are widespread. According to the scientists, the new JWST images show at least 1,000 times as many galaxies as theories predicted at a redshift greater than 10, suggesting that many massive galaxies may have formed rapidly. That suggests that there was no Big Bang, which is highly implausible. Let's stop here and consider what might happen. If the Sun's scientific community acknowledged the Big Bang Theory's flaws, then a new explanation for the origin of the cosmos must exist. Plasma filamentation, which has been probed for about 50 years, is one. This process may be explained by applying physical principles found in laboratories. Most matter in space, including stars and interstellar space, is made of plasma, an electrically conducting gas. Only the Hubble River and shift relation would require a new physical process to account for the energy loss that occurs as light travels over such vast distances. Plasma filamentation is one of the fundamental processes in plasmas that scientists have recognized and researched. This is the process by which electric currents and the magnetic fields they generate draw plasma into the lasing network of filaments observed at all scales across the universe. Plasma filamentation is one of the fundamental processes that gave rise to planets, stars, galaxies, and other structures. Plasma filamentation is also critical in the effort to create artificial fusion energy. The JWST is simply doing its job by introducing us to new ways of viewing the universe. It is already causing scientists to speculate on what would happen if the Big Bang did not occur. Betelgeuse star explosion. NASA chief just issued a serious warning. The second brightest star in the Hunter's eastern shoulder is Betelgeuse, also known as Alpha Orionis. Its name is derived from the Arabic word Bat al-Jawrs, which means the giant's shoulder. One of the stars in the night sky with a maximum brightness is called Betelgeuse. It is a variable star with an average apparent magnitude of around 0.6, but it started to dim in the late 2019. By early 2020, it had a magnitude of 1.6 and was back to its previous brilliance. This great dimming was brought on by a massive gas explosion that condensed into dust when it cooled. But even being 642.5 light years away from it, NASA thinks it's dangerous for us. So let's take a look why NASA chief just issued a serious warning. Betelgeuse is clearly visible to even the most casual observer due to its brightness. Location in the beautiful constellation of Orion and rich crimson hue, the star is roughly 642.5 light years away from the Earth. Betelgeuse initially gained attention in the late 2019 when the star, which gleams like a crimson diamond in Orion's upper right shoulder, unexpectedly darkened. In 2020, the supergiant's brightness deteriorated more. Scientists have been attempting to ascertain what transpired with the star since some predicted that it would go supernova. Astronomers have analyzed data from the Hubble Space Telescope and other observatories, and they believe the star experienced a titanic surface mass ejection, losing a significant portion of its visible surface. Observing Betelgeuse in its usual and unusual behavior has allowed astronomers to see what happens late in a star's life. Betelgeuse has grown to enormous proportions and evolved into a red supergiant as a result of burning through fuel in its core. The enormous star has a diameter of 1 billion miles. The star will eventually become supernova, which could briefly be visible from Earth during the day. The star is currently having some ferocious tantrums. Even losing a sizable portion of its surface mass isn't a warning that Betelgeuse is about to blow, according to scientists. Late in their lifetimes, stars can lose a large amount of mass when they burn through nuclear fusion, which can have an impact on their survival. Scientists think that a convective plume that was more than 1 million miles across came from the star itself. A portion of the star's photosphere was peeled off by an eruption brought on by shocks and pulsations that plume produced. The fragment of Betelgeuse's photosphere, which was several times heavier than the moon, was fired into space. When visible through telescopes on Earth, the star's light was obscured by the mass's formation of a huge dust cloud as it cooled. Being one of the brightest stars in the night sky, Betelgeuse's dimming, which lasted for a few months, was visible via observatories and home telescopes alike. Betelgeuse's cycle has been measured by astronomers for 200 years. The pulse of the star is essentially a cycle of fading in brightness that repeats every 400 days. Given how significant the eruption was, the pulse has temporarily stopped. Betelgeuse is progressively recovering, according to data from telescopes. But its surface is still springy while the photosphere is being rebuilt. The star's outer layer has also reverted to normal. Betelgeuse is still acting in an unusual manner, according to Dupree. The fact that a star has never before lost so much of its visible surface raises the possibility that surface mass ejections and coronal mass ejections were two entirely distinct phenomena. The James Webb Space Telescope will provide more opportunities for follow-up observations of mass expelled from the star and may provide more hints through otherwise unseen infrared radiation. This is intriguing because Betelgeuse, a red supergiant star that was observed to dim in brightness in 2019, sparking speculation that it may have gone supernova, is also a red supergiant star. Betelgeuse, it turns out, is nearing the end of its life, but according to a 2021 study, it won't explode for another 100,000 years. But what impact might this study have on Betelgeuse? However, the rust-colored star is the brightest star in the sky at near-infrared wavelengths. This star is visible to the untrained eye due to its brightness, position, and color, despite being approximately 640 light-years from Earth. Betelgeuse is a red supergiant star that is approximately 764 times the size of the Sun. The diameter of Mars's orbit around the Sun is 328 times that of the Sun. Infrared observatories from spacecraft have revealed that Betelgeuse is surrounded by massive shells of material that the star has clearly shed during episodes of mass loss over the last 100,000 years. The largest of these shells is nearly 7.5 light-years in radius. What if Betelgeuse stands in for the Sun? Betelgeuse is so massive that if it replaced the Sun, it would instantly engulf the inner planets. With its surface extending beyond Mars and possibly as far as Saturn, Betelgeuse's diameter fluctuates on a regular basis, because it is a pulsating star. So our planet is not safe even beyond its surface. Stars from within dust clouds and are dispersed throughout Morse galaxies. The Orion Nebula is an example of a dust cloud. Deep within these clouds, turbulence creates knots with enough mass that the gas and dust begin to collapse due to its own gravitational attraction. The material at the center of the cloud begins to heat up as the cloud collapses. This hot core at the heart of the collapsing cloud is known as a protostar and will one day become a star. Three-dimensional computer models of the star formation predict that spinning clouds of collapsing gas and dust may split into 2 or 3 blobs, explaining why the majority of stars in the Milky Way are paired or in groups of multiple stars. One type of supernova is caused by a dying massive star's last hurrah. This occurs when a star with a mass at least 5 times that of our Sun explodes with a spectacular bang. Massive stars use massive amounts of nuclear fuel at their cores or centers, because this generates a tremendous amount of energy. The center becomes extremely hot. Heat creates pressure, and the pressure created by a star's nuclear burning prevents it from collapsing. A star is in a state of equilibrium between 2 opposing forces. The gravity of the star tries to squeeze the star into the smallest, tightest ball possible. However, the nuclear fuel burning in the star's core creates a lot of outward pressure. This outward push counteracts gravity's inward squeeze. When a massive star runs out of fuel, it cools down. This causes the pressure to fall. Gravity trims and the star suddenly collapses. Imagine something 1 million times the mass of Earth collapsing in 15 seconds. The collapse occurs so quickly that it generates enormous shock waves, causing the star's outer rim to explode. A dense core is usually left behind, along with an expanding cloud of hot gas known as a nebula. A supernova that is more than 10 times the size of our Sun may leave behind the universe's densest objects, black holes. A second type of supernova can occur in systems containing 2 stars, at least one of which is an Earth-sized white dwarf. A white dwarf is what remains after a star the size of our Sun has depleted its fuel reserves. A white dwarf can explode if it collides with another or pulls too much matter from a nearby star. Sima Qian, a Chinese court astronomer, wrote about these star colors around 100 BC. White is like Sirius, red is like Antares, yellow is like Betelgeuse, and blue is like Bellatrix. According to Professor Ralph Neuhauser of the University of Jena, from these specifications one can conclude that Betelgeuse was in color between the blue-white Sirius and Bellatrix and the red Antares at the time. Independent of the above, the Roman scholar Hyginus described Betelgeuse as having the color of the yellow-orange Saturn some 100 years later. Thus, the former color of Betelgeuse can be quantified with even greater precision. Supernova explosions have been linked to mass extinctions on Earth, such as the one that occurred 2.6 million years ago, or the Permian-Triassic extinction 252 million years ago, which was the most devastating to Earth's biota, killing approximately 96% of all marine species and 70% of all terrestrial vertebrate species. Fortunately, Betelgeuse poses no danger to Earth. When it does explode, the deadly radiation will spread out eventually in all directions, and by the time it reaches us, it will be too weak to be of concern. Other supernova candidates, such as Wolf-Rayet stars, are far more dangerous. Some of these could produce a gamma-ray burst, which funnels radiation very narrowly along the rotational axis of the star. If Earth is in line of fire, the consequences could be catastrophic. The most famous example of this type of star, known as WR104, is too far away to pose a threat to Earth, but other, closer, Wolf-Rayet stars, such as the one in Gamma Velorum system, could be a concern. That is why learning more about stars on the verge of going supernova could be a lifesaver in the future. In the case of Betelgeuse, we'd get about an hour's notice before the bright explosion from neutrinos and gravity waves emitted before the shock reaches the star's surface and visible light begins to rapidly increase. SN1604, also known as Kepler's supernova. Kepler's nova or Kepler's star was a type Ia supernova that occurred in the Milky Way, in the constellation Ophiuchus. It is the most recent supernova in the Milky Way galaxy to be observed with the naked eye, occurring no more than 6 Solar parsecs, 20,000 light-years from Earth. Prior to the adoption of the current naming system for supernovae, it was named after Johannes Kepler, the German astronomer who described it in Die Stellanova. Kepler's star visible to the naked eye was brighter at its peak than any other object in the night sky, with an apparent magnitude of 2.5. It was visible during the day for more than 3 weeks. There are sightings of it in European, Chinese, Korean, and Arabic sources. Will Betelgeuse explode soon? It could explode today, in 100 years, 1,000 years, or 100,000 years. It's difficult to predict. The brightness of stars in the supergiant phase of stellar evolution varies. Betelgeuse is known as a variable star, with brightness variations lasting years to decades. The current brightness drop was abrupt and severe, with Betelgeuse appearing only about half its usual brightness in the sky. Does that mean it's about to blow up? Probably not, but sky watchers all over the world are hoping Betelgeuse will go supernova soon. Record. Webb just discovered the oldest star clusters. The launch of NASA's James Webb Space Telescope, collaboration with the European Space Agency and the Canadian Space Agency, marks the beginning of a new era in astronomy. On July 12, 2022, at 10:30 a.m. EDT, at NASA's Goddard Space Flight Center in Greenbelt, Maryland, the telescope's first full-color photos and spectroscopic data were made public. We will have a look at the official launch of Webb's general science activities, as well as the observatory's initial collection of full-color scientific images and spectra coincide with the targets. An international committee that selected them was made up of representatives from NASA, ESA, CSA, and the Space Telescope Science Institute. So let's have a look on what Webb just discovered. The information in these pictures relates to the early cosmos, star birth and death, galaxy collisions, and exoplanet atmospheres. Moreover, they're stunning. In contrast to earlier telescopes, this one lacks the smudgy, pastel quality. As light is being painted, the clarity and sharpness of the painting may cause you to think of Vermeer. The deepest and brightest infrared image of the outer reaches of the universe has yet been captured by NASA's James Webb Space Telescope, Galaxy Clusters SMACS 0723, which is part of Webb's first deep field, is teeming with hundreds of galaxies, including some of the most faint things yet seen in infrared light. Webb's image represents a minute fragment of the huge cosmos, approximately the size of a grain of sand held out at arm's length. This galaxy's cluster's total mass serves as a gravitational lens, enlarging galaxies that are farther away, including some that were discovered when the universe was only a few billion years old. This infrared deep field was captured by Webb's near-infrared camera. It is a composite constructed from photos collected at various wavelengths over the course of 12.5 hours, surpassing the deepest fields captured by the Hubble Space Telescope, which took weeks to complete. This is just the start, though. Longer exposures will continue to be taken with Webb by researchers and showing more of the enormous universe. The galaxy cluster SMACS 0723 is visible in this image as it would have been 4.6 billion years ago, with a great number of other galaxies in front of and behind the cluster. As experts delve deeper into Webb's data, much more about this cluster will become clear. The mid-infrared instrument on Webb, known as MIRI, also captured images of this field. Billions of years have passed before the light from these galaxies reached us. Viewing the youngest galaxies in this universe, we are looking back in time to within a billion years of the Big Bang. Webb was designed to observe infrared wavelengths, which were produced as a result of the universe's expansion stretching the light. Soon, more information about the galaxy's masses, ages, histories, and compositions will be known to researchers. In addition to taking photos, two of Webb's instruments also gathered spectra, which are data points that reveal an object's physical and chemical properties and will help specialists in this field understand more specifics about distant galaxies. A brand new technique employed for the first time in space. Webb's near-infrared spectrograph observed 48 distant galaxies at the same time and returned comprehensive information about each. According to the findings, one galaxy's light traveled for 13.1 billion years before being caught by Webb's mirrors. Webb's near-infrared spectrograph data also show how finely detailed galaxy spectra will be with Webb observations. Hubble has already captured a picture of the SMACS 0723. Although the photos look fairly similar, the JWST image is richer and provides an unprecedented perspective of thousands of distant galaxies. The new space, which has a better light gathering capability, was able to capture images of numerous distant galaxies in the same region, including some of the most faintly lighted objects ever spotted in the infrared. Some of the galaxies in the images are depicted as they were more than 13 billion years ago, when the cosmos was still extremely young. Webb has received a number of cutting-edge technological developments. Included in these is a main mirror consisting of 18 different parts that unfold and assume their final configuration after launch. Exceptionally light beryllium is used to make the mirrors. A 5-layer sun shield the size of a tennis court that attenuates heat from the sun more than 1 million times in Webb's most notable feature. The spectrometer and cameras, which make up the telescope's 4 instruments, contain detectors that can capture incredibly low signals. Up to 100 objects can be discovered simultaneously by one device, which features customizable microshutters. The mid-infrared detectors of another instrument on Webb are likewise cooled to an extremely low 7 kelvins so they can function. The James Webb Space Telescope provided a magnificent variety of galaxies in that photograph, which was its first deep-field view, and a group of Canadian scientists has focused on a galaxy that is 9 billion light-years away from Earth and is known as the Sparkler Galaxy, because the compact objects that surround it look like tiny, shimmering yellow-red dots. The galaxy itself is remarkable due to its strange stretched appearance, but the nearby objects that give rise to the term are of great scientific significance, as they may be the farthest globular clusters of stars yet discovered by scientists. Globular clusters are collections of ancient stars that have existed since the beginning of a galaxy. As a result, they may contain knowledge about the early stages of galactic formation, growth, and evolution. The Canadian NIRISS Unbiased Cluster Survey team examined the 12 compact objects that surrounded the Sparkler Galaxy and discovered that 5 of them are in fact globular clusters. Furthermore, these might be some of the oldest globular clusters ever discovered, possibly existing at the moment the cosmos first started to form stars. About 150 globular clusters are thought to be present in the Milky Way, although their ages are unknown. According to Mawla, while most things in our galaxy can be age-dated rather readily, this isn't the case for truly ancient objects. Mawla also remarked that these objects appear older when seen up close and are therefore older in time. When the cluster was much younger and the universe was only 4.5 billion years old, it was much simpler to date distant clusters like the Sparkler Galaxy, which astronomers say as being 9 billion years ago. How much the SMACS 0723 galaxy cluster, which acts as a lens for the Sparkler Galaxy, is magnifying it, is one of the unanswered questions. I remarked, the magnification of the Sparkler Galaxy and its environs is not as well constrained as we'd want. So, one of the things we would want to do is to construct a better magnification model so that we can determine if it's enlarged by a factor of 10 or by a factor of 100, says the researcher. The research team's theory is that these sparkles are either older globular clusters or young, actively growing star clusters that formed 3 billion years after the Big Bang at the height of star formation. Globular clusters are old collections of stars that date back to the creation of a galaxy and reveal details about the early phases of its growth and expansion. The researchers found that 5 of these compact objects are among the oldest known globular clusters after performing an initial investigation on 12 of these compact objects. Globular clusters, which include tens of thousands to millions of stars, are stable, firmly bound clusters. They are connected to all different kinds of galaxies. Globular clusters are strongly gravitationally bound and often larger than open clusters. A star cluster is one of the two types of stellar assemblages that are bound together by the gravitational pull of their individual members who are linked together physically by a shared origin. Open clusters are also known as galactic clusters, and globular clusters are the two forms. Open clusters typically have an asymmetrical configuration of several dozen to hundreds of stars. Contrarily, globular clusters are ancient systems with tens of thousands to a few hundred thousands stars packed together closely together in a symmetrical, nearly spherical structure. Also identified are associations, which are collections of a few dozen to several hundred stars of familiar and similar size and origin, but with a lower density in space than the surrounding field. By the beginning of the 21st century, the Milky Way galaxy included more than 150 globular clusters. The majority are widely dispersed throughout the galactic plane, while roughly a third are clustered as satellite systems in the dense star fields of Sagittarius and Scorpio, close to the galactic center. The apparent diameters of individual cluster masses range from 1 degree for Omega Centauri down to knots of 1 minute of arc, and their linear diameters can be several hundred light years. Each cluster mass contains up to 1 million suns. In a cluster like M3, 90% of the light is contained within a 100 light-year diameter, while star counts and research on the member stars of RR Lyrae, whose intrinsic brightness varies periodically within well-known bounds, include a wider 325 light-year diameter. The concentration of stars in the centers of the clusters varies significantly between them. Some of them, like Omega Centauri, are clearly elliptical despite the fact that most of them appear round and are most likely spherical. M19, with its most main axis about doubling that of its minor axis, is the most elliptical cluster. The Milky Way galaxy, a massive star system of which the Earth is a minuscule part, has two satellite galaxies, one of which is the Magellanic Cloud. The Magellanic Clouds are a pair of irregular galaxies that are 22 degrees apart and share a gaseous envelope. They are located close to the south celestial pole. The small Magellanic Cloud, which is less than 2 degrees across, and the large Magellanic Cloud, which is around 5 degrees across, are the two distinct luminous patches. The importance of the discovery lies in the fact that these globular clusters are more than 13 billion years old. They are one of the oldest clusters that we have ever found to date. Furthermore, their color is consistent with stars originating in the first 500 million years of the Big Bang. That's the same time astronomers believe the first galaxies started forming. If these ages are confirmed, the clusters appear contemporary to the large-scale reionization of the intergalactic medium, hinting at a deep connection between globular and cluster formation in initial phases of the galaxy assembly. Gravitational lensing is one of the most important physical phenomena for the astronomers studying the distant universe. It magnifies and exposes those objects and regions of the cosmos that worldwide remain out of sight, and no one knows how much deeper Webb will take us. So, what are your thoughts on these amazing discoveries?
Hubble telescope observed an odd black hole. Black holes are among the universe's most intriguing and puzzling things. A black hole's strong gravity, which is one of its primary characteristics, also makes it challenging to examine. The event horizon is a barrier around which the entire mass of a black hole is contained in a small area. Nothing, not even light, can pass that line and return to the outside world. The black hole itself cannot be seen. However, by seeing how black holes' gravity affects stars and draws matter into orbit, astronomers may still indirectly view black holes. Black holes are unseen objects that paradoxically become some sort of the brightest things in the cosmos, as gas swells around them and warms up. Because of this, certain black holes are visible to us from billions of light years away. However, not all black holes are predators. In fact, the Hubble Space Telescope has shown that some can even produce. What is the origin of this black hole? In this video, we will learn why it is generating rather than destroying. Hubble Space Telescope has dazzled the globe with views of space and a fuller understanding of how the cosmos functions since its launch in 1990. Despite its age and small size, the Hubble Space Telescope is still among the greatest in the world. The 2.4 meter Hubble mirror, with optics that are reaching their third decade of usage, is rather ordinary for contemporary research telescopes, when compared to the enormous 8 to 10 meter telescopes constructed on the ground, with much larger ones planned in the future. Although the demand for its use in research continually outstrips the amount of observing time available each year, it is still regarded as the best optical and ultraviolet telescope because it constantly exceeds several of the most sophisticated ground-based telescopes. The success of the Hubble is in large part thanks to its location far above the atmosphere, where it is free from many factors that confound observers on the ground. In fact, because of the presence of substances like ozone that absorb ultraviolet light in the higher atmosphere, UV astronomy is all but impossible to do from the ground. Hubble is able to capture some of the clearest and most in-depth photographs of our universe. Because of this, and due to the absence of the turbulent air currents that give stars the appearance of sparkling, it contributed to the discovery of the universe's age, which is today estimated to be 13.8 billion years old, roughly 3 times the age of Earth. Nix and Hydra, 2 moons of Pluto, were also found. It even helped to figure out the rate at which a universe is expanding. Revealed that a black hole is located at the centre of almost every big galaxy. Produced a 3D map of dark matter and accomplished much more. But even the experts were taken aback by the most recent finding uncovered by the Hubble Space Telescope. A black hole that is not behaving like the destructive monsters they are frequently depicted as, has been seen by the Hubble Space Telescope at the centre of a dwarf galaxy. Instead of devouring stars, this black hole is actually producing new ones. The dwarf galaxy Heinze 210, which is located 30 million light years away in the southern constellation Pyxis, is home to the black hole. A firestorm of new star formation is reportedly occurring in the galaxy as a result of the black hole, according to NASA. Heinze 210 was the subject of much discussion 10 years ago on whether or not dwarf galaxies harboured supermassive black holes comparable to those found at the centres of big galaxies. Heinze 210, which contains only 1/10 of the amount of stars in the Milky Way, may now play a significant part in the discovery of where supermassive black holes emerge, because a black hole has been found at its core and it's not behaving as expected. Amy Reines, who released the initial evidence of a black hole in the Heinze 210 galaxy in 2011, is the primary investigator of this new data, which appears in the January 19th issue of Nature. From the beginning, I knew something unusual and special was happening in Heinze 210, and now Hubble has provided a very clear picture of the connection between the black hole and a neighbouring star-forming region located 230 light-years from the black hole, Reines said. The formation of stars is uncommon and distinct from what is found in larger galaxies. Gas may be observed flowing around the black hole at the heart of Heinze 210 before collapsing into a thick cocoon of gas within the galaxy. Hubble spectroscopy shows the outflow was moving about 1 million miles per hour, slamming into the dense gas like a garden hose hitting a pile of dirt and spreading out. Newborn star clusters dot the path of the outflow spread. Their age is also calculated by Hubble, NASA explains. Contrary to what is observed in larger galaxies, when elements falling towards the black hole are redirected by magnetic fields encircling the region, creating flaming plasma jets that travel at speeds close to the speed of light. This is the opposite. Gas clouds caught in that path would be heated to a point where they would be unable to return to a cold state and develop into stars. But the Heinze 210 black hole's softer outflow of gas has exactly the right amount of compression to promote star formation. A pullout of the dwarf starburst galaxy's central region, Heinze 210, traces a 230 light-year long outflow, or bridge of hot gas linking the galaxy's huge black hole with a star-forming area. Hubble data on the velocity of the black hole's outflow as well as the age of the newborn star points to a causal relationship between the two. A few million years ago, a burst of hot gas blasted into the dense cloud of a star nursery and fanned out, like water from a hose striking a mound of dirt. clusters of newborn stars are now arranged perpendicular to the outflow, indicating its route. At only 30 million light years away, Hermes 210 is close enough that Hubble was able to capture both images and spectroscopic evidence of a black hole outflow very clearly. In order to understand how space, time, light and gravity fit together, it may be helpful to analyse the light coming from the black hole disk. The universe continues to surprise us in unexpected ways, especially when it comes to the secrets of black holes, as evidenced by this incident. So what are your opinions on this latest revelation about black holes? It will alter our perspective of these massive eaters, and we may begin to perceive them as creators as well. This could validate notions of existence on the other side of these huge voids, ushering in an entirely new age of space and exploration. Thanks for watching guys, and we'll see you in the next video. We hope that you have a lovely day.